Welcome back, and in the last video we introduced the angle addition and angle difference formulas for sine, cosine, and tangent. Now this video is just going to kind of go through some more examples, so watch it as needed. I will say though, I want you to try each of these examples and then resume the video to see the solution. So you can see two examples on the screen. Again, I want you to pause and try them out. Resume when you're ready to see the solutions. And here are the answers. So for the first one, tangent of 165, I recognize that 165 is 120 plus 45, and then broke it down into that within tangent, and then used the tangent identity for angle addition, and then I had to figure out what tangent of 45 was and tangent of 120. So for tangent of 45, I just know that that's 1, because you have square root 2 over 2, square root 2 over 2, and then 1 for the hypotenuse. When you're at 45 degrees for 120, I had to make a little sketch, so I know 120 degrees. That meant that this little angle down here, this reference angle, was 60 degrees. So then I could create my triangle and then include the appropriate signs due to the quadrant. And so then I got the end result of square root of 3 plus 1 all over 1 minus square root of 3, and I would leave that. Okay. For the next one, this one was actually a little bit more challenging. So first, what I did is I wrote out what cosine of alpha plus beta was according to the identity, which is cosine alpha cosine beta minus sine alpha sine beta. And then the next part was figuring out each of the values. Some of them I were given, right? Like I have sine of alpha is 5/13 and cosine of beta was 5/6. So like those two I knew, but I had to figure out these other two. And for that I had to make little sketches. So alpha, it said, was in effectively quadrant 2, right? And then once I'm in that quadrant, I use the information for alpha that I was given, so sine was 5/13, to find the missing side of minus 12. That's a Pythagorean triple. And for beta, similar thing, it's in quadrant 4, so then I had to draw a little sketch, say that cosine was adjacent over hypotenuse, so 5/6, and then that left negative. I shouldn't have negative 11, negative square root of 11 there, so then I need to modify that answer, so that's a plus. I digress, so then just do the calculation, 12 over 13, so use the triangle that you set up to find the missing values, and we go on from there. Okay, so that is a couple examples that are reasonable for applying the angle addition and difference formulas. Two more examples. This third one is something that we could ask of you on a quiz or something like that. The other one, a nice little application that I want you to give a shot to. So again, pause the video, try these on your own, and then resume the video when you're ready to see the solution. And for this third one, this one is a little bit more straightforward. It's a little deceiving. You have to actually start with the right-hand side and prove the left-hand side. If you start with the right-hand side, then you just use the angle addition or angle difference for cosine and get sine. For this next one, this one's a little bit more challenging because the immediate way to start isn't super clear. But we know we want to express it in this form, so we want to take sine of t plus alpha, and if we were to write it out, it'd be sine of t cosine of alpha plus cosine of t sine of alpha, right? So then, kind of looking, we want to look for that pattern in here, and so we see that, you know, there's this 3 and this 4 that seem to match that cosine of alpha sine of alpha, but again, for cosine and sine, they can only put out values between 1 and -1 for their range, right? So I'm going to end up factoring out this 5. So this 5, what it is, it's, if I were to complete a triangle, right? I could imagine, you know, this is -3 and this is 4, and then this hypotenuse would be 5. Well, I could rescale the sides, use a similar triangle where I just say, okay, now the hypotenuse is 1 and this is 4/5 and 3/5. Okay, so that's what I did, is I pulled a 5 out, so I removed a factor of 5, and then when I did that, I got -3/5 and 4/5. Okay, and now comparing this black equation to this black equation here to this identity over here, those two facts together and mean that cosine of alpha is minus 3/5, sine of alpha is 4/5, and then if you draw a little triangle, that puts alpha in quadrant 2, and so then to get the correct angle here, you could try sine inverse sine of 4/5, but that isn't going to give you the right range due to the range of inverse sine. But if you use inverse cosine, then you get the angle being in the second quadrant, so that's going to be our angle. So all said and told, we get the desired form of 5, and then we get our alpha to be cosine inverse of minus 3/5. Okay. Now this example again is a little bit beyond what we might normally expect in a quiz, but something interesting to think about in connection to angle addition and angle difference.